Welcome to lesson 12.3. Today we're going to look at tangent lines and velocity, but before we do that, let's review limits, and specifically in lesson 12.2, we didn't just review limits, we were looking at them algebraically. So I'm going to do algebraically, as well as you can see I have Desmos open on the left. I will go over what we did in lesson 12.1, which is seeing them graphically. So algebraically, we learned a few rules, specifically that when you evaluate a limit that's a polynomial function, this is polynomial. That means all powers are whole numbers, and none of the powers are negatives. So they're counting numbers, basically. And you might say, well, what about the 1 here? It doesn't have a power, and this x doesn't. Well, x is the same thing as x to the first, and just a number by itself. It's kind of like x to the 0. Whole numbers are the numbers from 0 counting up that are not decimals, not fractions, and positive. So this would be polynomial. So you could use direct substitution, which means to discover this limit, we would just plug in -2. So the limit would equal 1/2 times, instead of here x cubed, I'm going to change that to -2 cubed. I'm putting substituting in parentheses, especially, this is very important always, but especially when it's a negative, just because you use technology to make sure you get the correct solution. The technology will follow PEMDAS, and it could give you an incorrect solution if you do not place that negative right, or the parentheses around it. Okay, so that's what I would be directly substituting. In this particular case, -2 cubed means -2 times a -2 times a -2. 3 -2s, when you're multiplying, will end up with being a -8. So we have 1/2 times -8. -5 times a -2 will equal a +10 plus 1 more. And 1/2 of -8 is -4. So -4, and then 10 plus 1 is 11. So -4 plus 11 will end up equaling 7. So that's using direct substitution right there. We get this value 7. Now, if you wanted to see graphically, you would graph 1/2 x cubed minus 5x plus 1. We would take out this graph, and if you wanted to at the front, you could do like f of x equals, just like that. And you would be checking, what does this graph approach as we, what does the y value approach as the x value approaches -2? So from the left and the right, as we approach this value here of -2, you can see these are counting by ones. That's -5, so -1, -2. As we approach this value right there, you can see that both from the left side and the right side of this graph, we're approaching the y value 7. And if you want to check what the table, whoops, that's not what I meant to do, table like this, we want to approach -2. So I'll kind of get some numbers that are close to -2 here, -2.01, and we'll do one more, -2.001, -2, -1.99, -1.9. You can see how this, I missed one here, -1.999. You can see as we get closer and closer to that value -2, both from this would be the left side, this would be the right side. You can see the number we're approaching is that 7 rather. So that'd be the answer to -1, or number 1. Sorry, number 1 would be 7. All right, let's take a look at number 2. Now we're looking at a rational function. So rational is where you have a polynomial divided by another polynomial, and we learned we can use direct substitution on this, borrowing that when you plug in the 4, you're not dividing by 0. So I'm going to check that real quick. We'll have 4 minus 1, I'm sorry, over 4 squared. And here, I'm a positive number, so it's not as critical to put the parentheses, but I will still use parentheses. 2 times, substituting in 4, plus 3. That will not equal 0 because all these numbers are positive that are adding together, so certainly that'll be a positive number. So let's just see what that equals when I simplify. I'll have 3 divided by 4 squared is 16. 4 times 4 is 16. Plus 2 times 4 would be 8. Then plus 3 more. So it looks like to me it'll be 3 over 16 plus 8 is 24. Plus 3 more is 27. And this can simplify. 3 goes into 27 9 times. So this would just be 1/9. So D would be the solution. Let's check this one out. We'll call this one g of x equals x minus 1 over x squared plus 2x plus 3. And turn this one off. And you can see as we approach the value of 4, so here's where I'm approaching. As I approach 4, it seems to me when I look on this table here that it's like 0.11111. Now what is 0.1111? It's 1/9. So you can see that's true. And again, if you wanted to use the table, you could. Specifically, we're looking as x closes in on the value 4, so I could do like 3.9, 3.99, 3. And I'll do 3 9s, and then I'll do a 4. Do kind of the same thing. 4 plus 1,000th, 4 plus 100th, and 4 plus a 10th. And just like that, you can see that it's approaching the value of 1/9. And now number 3. On this problem, notice it's a polynomial divided by another polynomial, which we call rational. But if I directly substitute in -3, I have a problem. If I substitute in -3, I would have -3 plus 3, which is going to equal 0, and you're not allowed to divide by 0. So this is one that we would need to factor first. And so the numerator, I'm going to use X method factoring. I'm going to say this has an A value of 1, a B value of 1, and a C value of -6. And so when we learn how to do X method, this was lesson 03 or 1-0, if you will, the very first lesson of the school year. You learn you multiply A times C, we got -6, and the B value was 1. So we're looking for factors of -6 that add up to 1. When I taught this lesson, I said 2 variables, M and N, that multiply to give you a product of -6, that combine together to give you a sum of 1. I know the numbers are going to be 2 and 3. To make it be a positive 1, it would have to be 3 minus 2, and you can check it. -2 times 3 would be -6. So those are my 2 numbers. What we would do next is you split the A term's power. And so we'd have an x to the first, or 1x to the first minus 2 times 1x to the first plus 3. And if you happen to have an A value that's greater than 1, you would have to do bottoms up step. But I don't this time. So I'll just leave it like that over x plus 3. So this is an equivalent expression to this limit here. And you can notice that I could simplify these factors. And so I'm basically saying, what's the limit as x approaches -3 of x minus 2? And using direct substitution, we'd have -3 minus 2 more, which is going to give us -5. Now let's go check out this graph. Turn it off. We'll call this one h of x. H of x will equal x squared. This will be over x plus 3. X squared plus x minus 6. So it looks like a straight line as we approach the value -3. Let's see, -3.01. Oh, I'm doing this backwards, sorry. -3.1, -3.01, and then -3.001. Okay, so I'm closing in on the value -3. You can see it's undefined. That's because you're not allowed to divide by 0, so the function itself is undefined. But as 2.999, let me get these in there. 2.99 and then -2.9. So you can see that these values are closing in or approaching the value -5. It would be an open circle in there. Let me get this. I got to zoom way in. Right there, you can see it's an open circle. It's undefined, but that doesn't mean the limit doesn't exist. That means h of x might not exist there, or this function right here won't exist at -3. But graphically, we see that the limit does exist, and that limit was -5.